Okay, let's apply what we know about inequalities and what we know about problem solving to answer some questions that are dealing with real life. So, Xavier is taking a math course in which 4 tests are given. To get a B, he must average at least 80 on the 4 tests. So before I start looking at the other numbers, this is key here. We're looking at the average of the 4 tests. So Xavier's average must average at least 80 on the 4 tests. So his average has to be at least 80. So it could be 80. 80 is at least 80. Or it could be 85 or 95, right? At least 80 means it has to be more than 80, or at the bare minimum equal to 80. That's what at least translates to, greater than or equal to. His average has to be greater than or equal to 80. Okay, well, what is the average? In this case, they're talking about the arithmetic mean, the mean average we're used to. We've got tests A, B, C, and D, 4 tests, right? 4 tests. And you add up your scores on all 4 tests. And we're saying that average has to be more than 80. All right, well, fine. Maybe he got 100 and 100 and 60 and 60. Well, that's not the case. We already know what he got on those first 3 tests. His first test is 87. He got scores of 87, 75, and 79 on the first 3 tests. 87, 75, and 79 on the first 3 tests. Determine, in terms of an inequality, what scores on the last test will allow him to get at least a B. So what does this last test have to have as a score? D is maybe going to look like a 0, so I'll just use x, because I'm boring, divided by 4. So this calculation, we want him to get at least a B. So that calculation has to get to greater than or equal to 80. Now, it doesn't say at least 79.5. Right? We're not looking at whether the teacher has a rounding rule, saying at least 80. So we want this to be at least 80 exactly. Now, how do we solve this? We could try dividing each of these by 4, right? Distribute that 1/4. That's going to be ugly fractions. Better, now that we have our model here, better to multiply this whole expression by 4 and this whole expression by 4. 4/4 is 1. Now we just have 87 plus 75 plus 79 plus x. 8 times 4 is 32. So that's 320. Now, did we multiply by a negative value? No, we multiplied by a positive 4. So this doesn't change. It's still greater than or equal to. Now, at this point, we need to get rid of these terms so that x is by itself. We could subtract 87 from both sides, then subtract 75 from both sides, then subtract 79 from both sides. But that's going to take you a while. Better to add all of these up. 87, 75, 79, 7, 8, 9, 10, 11, 12, plus 9 is 21. 8, 9, 10 plus 14 is 24. So 241 plus x is greater than or equal to 320. Now I subtract the 241 from both sides. 320 minus 241, I gotta borrow. 10 minus 1, gotta borrow. 11 minus 9, 2 minus 2 is 0. X is greater than or equal to 29. That doesn't quite seem right here. It could be the case if he aced his other 3 tests, maybe he could really bomb his last test and still have an average more than 80. But he only got higher than 81 out of the 3 times. I've made a mistake. So let's try this again. 320 minus, where is this? This is what did it. My handwriting caught me up. 87 plus 75 plus 79 is 241. 241. But when I write my 4s on the screen here, sometimes these kind of close. I read that as a 9, but it's really a 4. So when I borrow here, 10 minus 1 is 9. I'm not doing 1 minus 4, I'm not doing 1 minus 9, I am doing 1 minus 4. 11 minus 4 is 7. 2 minus 2 is 0. So it's not x is greater than or equal to 29. It's x is greater than or equal to 79. That seems more realistic. I got a little bit below an 80, a little bit below an 80, a little bit above an 80. So if it turns out if I get almost exactly an 80, then I'll stay with an average of 80. And we can actually show that on a number line. An average is sort of an arithmetic average like this. It's kind of the center of gravity. So if I look at 80 here, if that's going to be my average, this smaller. 87 is 7 above that. So I start out with a surplus of 7. But then 75, that's 5 below that, so I'm down by 5. Up 7, down by 5, that means I'm only up by 2. Right, 7 minus 5 is 2. So right now, the average of these two is 82. I want to bring that, that's good. I got a 79 here, that brings it down by another 1. Well, if I get another 79, if I bring it down by 1 twice, that's going to bring my average back to 80, right? My weight above my average is positive 7. My weight below the average is negative 7. That's what makes 80 the average. Right? So sometimes we can use this kind of shortcut to avoid all of this math. If this was confusing to you, if that's not something that intuitively you're like, oh yeah, I see that, then don't worry about it. You don't need to know how this works in order to do the problem. This is a more robust approach. Even if the numbers are messy, this approach will always work. It's just as straightforward. Right? Now, as always, when we're answering a question, we need to answer the question, right? Determine, in terms of an inequality, what scores on the last test will allow him to get at least a B. So we can say, with all confidence, Xavier can score at, what was our limit here? Greater than or equal to 79. So he can score at 79 or higher on his 4th test. Right, that's what we're looking at here.